All right. So things have been confusing. It's all having to do with this whole COVID-19. I understand that. You were broken into 3 different groups because we cannot have more than 10 students at a time in this space. So when you meet with me, it kind of counts as both your lecture and your lab. So at this point, what should you be doing? Here's the things that you should do in Blackboard. Number 1, you should read chapter 1, and at this point read chapter 2. And at the end of reading chapter 1 and chapter 2, you're going to go to the workbook. Well, actually, you're going to go now to the quiz section, and you're going to do the workbook quiz for chapter 1 and chapter 2. So chapter 2 is safety. Chapter 1 is this sort of introduction to what is an HVAC worker. And there's going to be a bit of that I'm going to talk about today with you. I think the really important piece of chapter 1. And I'm going to talk about safety. All right, other things you need to do, because this is a career readiness course program. My objective here is to get you a job as an HVAC worker. By the way, anybody have a job in an HVAC company right now? No. Okay. All right, so that's at the end of our time together over these 2 years, that's why I'm here. Not just to get you a job, but to get you a better job, working for a Train or Linux or any of those big names, Dakin. Those are the ones that, where you make $100,000 or more a year. That's why I'm here. They're going to pay you that amount because you'll have skills that you learn here that they want to make use of. And there's a lot of demand for HVAC workers out there. So in order to prepare, I added into Blackboard. You don't need an access code. All you need is to go into the course in the learning module, table of contents, and go to that first section, and using Resi, a free resume maker, make yourself a resume shell. Once you make it, you're going to convert it into a PDF, and then you're going to upload it into Blackboard. And that's how I'm going to grade it. So I need you to make sure it's a PDF file. You're also going to do the same thing with a cover. Yes?
So if you have a resume, you want to do the resume?
Yeah. If you have a resume and you're totally happy with it, then upload it. Okay? If you don't have one, or if you want to see what this Resi program, which is free, and also does a really nice job of building resumes. It really makes it look sharp. Cover letter. That's the letter that introduces you. It's kind of like a pre-resume, but it's what a resume is very specific, dates from to, specific job, things, tasks that you've done, accomplishments. A cover letter is a little softer. It allows you to sort of say, look, you really need to hire me because I come in, my attendance is great. I'm highly reliable. That sort of thing. These companies like it when you come in, you interview, and then you come back and you say, and you write a thank you note for them. Some potential employers, for HVAC I'm talking about, I'm not talking about anyone else, I'm talking only about the people that I work with and those employers. They like that. They also like it when you go there and you've done some research about the company. You look at their website, you kind of figure out are they both residential and commercial. You get a feel for the company, the mission, and a lot of this stuff's available on the internet. So they like it that you've done some research. Again, all these uploads, resume, cover letter, thank you note, make sure they're a PDF file. Other business. What I've done, because there has been, even though this was a asynchronous class, There wasn't an intention to have another Zoom meeting or video conference. What I've done is I've added it anyway. So if you're available on Mondays at 1 p.m., there's going to be a conference. There'll be a conference call, Zoom meeting or what have you. So hopefully you've received this information from my email or through a discussion or through somehow, that it's not brand new information. So you take your smartphones, you sync them to your Suffolk email account so that you look at your phone and say, oh, I just got a message. This has been added, this test is due, that sort of thing. It's there to remind you what's happening. So Blackboard, you're going to make sure you go in that and look it over, know where the quizzes are, where the assignments are. Other thing, open lab, because there should be 24 students in this room right here. If this was last year this time, that's exactly what you would see. 24 students in here, and in here for the lab only. So this room was converted into a multi-purpose room, classroom and lab. But you would be in a much tighter space, I assure you. Because of that, what I've done is I've added what's called an open lab. Now you probably heard me talk about this or seen it in the video or something. An open lab is a homework assignment where you come in during those open lab periods and you complete the 17 lab activities that I've selected for this course. The first one that you should be working on and setting an appointment for is identifying system components. I think it's lab activity 3 or 4, I don't remember. But that's what you should do. So you should print out a copy of that lab activity, make an appointment 24 hours ahead of time on those days that I listed as open lab days, which includes a Saturday morning session from 8 a.m. to 12. And you come in on your own. If you finish the thing in an hour, that's great. First off, there's no obligation that you do this, but you'll need to do it in order to do the lab activity. But it's up to you what time. There's a Monday session, a Tuesday morning and evening. Wednesday is being used for classes. Thursday in the evening and Saturday morning from 8 to 12. Those are your times. So we're going to mention, any question about anything I just said? We okay so far? All right. Chapter 1 was about, I'm just going to get rid of this upper part here. Chapter 1 spoke about career paths. The intention of all that was to convey to you that it's not just being the fellow that's in the van out there doing a service call, or even the multiple people in the van who are going to a job to do a new install. They are HVAC designers, they're HVAC salespeople, and all these different jobs, HVAC engineers, all these different jobs require different kind of training. But the basic training for them all is the same. And the basic training for them all is what you're getting here at Suffolk. Because from this program, then if you want to be an advanced technician, you can. If you want to go on to be an engineer, you can. So this is your foundation right here. So regardless of what path you take, it leads you to the same place. The last part of chapter 1 is the part that I really wanted to speak to you and all those watching this, is this part. It talked about certifications. Certifications and licensing. Number 1, the most important license that you have when you go out this summer, this coming summer rather, next summer, is a driver's license. Yes, a New York State driver's license. And the most important thing you can do in this career is keep that driver's license clean. Because everywhere you will apply, the owner of that company has insurance. The first thing the insurance company will ask him to do for any potential new hire will be to get a transcript of your driver's license. And it will list all the violations that you have. And if it comes back and the insurance company says, I'm not going to insure this guy, then you're not going to get a job. The most important license for you to take care of is your driver's license. There is really no HVAC/R jobs that you do in a setting like this. There are some factory jobs. There's a company on Long Island. They build HVAC, what we call PTAC units. PTAC stands for Package Terminal Air Conditioning. In other words, they build those units that you see. They put them up on the roof. They cut a hole, and everything's in that box. It's like installing a window box air conditioner. There is a company that makes those, and you can go to work there. But 99% of the jobs are on the road jobs, over the road jobs. That license, extremely important. The next license you need, the next certification you need, is this, EPA. It stands for Environmental Protection Agency, and this is going to be a written test that you will take in the springtime that we'll offer to here for you. It's called EPA Section 608. And it's also known as refrigerant handling license. This EPA exam is required by the federal government. So it was part of legislation through the Clean Air Act. It is administered by the Environmental Protection Agency. This refrigerant handling license, just like that driver's license was foundational, was key, in order for you to work for an HVAC company and to help them charge a unit, recover refrigerant from a unit, store refrigerant, dispose of refrigerant cylinders, anything that involves the handling of refrigerant, you must have the EPA Section 608 license. And that's for handling refrigerant. It's a federal requirement. Now, different municipalities like New York City and other places will have their own rules and other mini licenses that you'll be obligated to obtain. But universally, across the nation, the United States, whether you're in North Dakota or Florida, this is a license you'll need, and that includes New York. It's 100 questions, all multiple choice. And none of it is about anything with electric. It's all about handling refrigerant. So they want to know that you know how to use a manifold gauge set. You know how to charge a system. That means add refrigerant into a system. That you know how to remove refrigerant from a system and store it in an external container without releasing it to the atmosphere. That's the point. So that's the license, and that's what they're going to teach you. And I have in the learning module, the Blackboard module in HVA 121, you'll see a thing there that says EPA, EPA something or another, EPA, I forgot exactly, it didn't say EPA. In that, it has the PowerPoint slides from the company who administers the test. The test is done online. It's through ESCO. They have their PowerPoint presentations that are voiceover, and they have, most importantly, their practice tests. Let me say that again, their practice tests. So you read the information, you take their practice test for free as many times until you get 100, 100, 100. When you come back here, you pay the money to take that test, then you're going to get your refrigeration universal license on the first sweep before your rear end leaves the chair. Now there's other certifications that are not required by law, but they are recognized as industry standard. So the industry that you're in is heating, air conditioning, and commercial refrigeration. So a couple of those organizations that are part of this industry standard, the first one that comes to mind is ASHRAE, the American Society for Heating, Refrigeration, and Air Conditioning Engineers. And we're actually going to learn very early on some rules that are ASHRAE standard rules from the industry. There's another one, it's called, how many of you own cars? How many have taken your car to get repaired? Okay. Now at the repair shop, did they have this thing that said ASE certified? You ever seen that? All right, I got a few guys. That stands for Automotive Society of Engineering, ASE. So you go there, the idea is you say, okay, this mechanic is ASE certified, so my car is going to be safe. The air conditioning, refrigeration, and heating has the equivalent to that, and it is this, and you should be aware of this one. It's NATE, NATE. It stands for North American Technical Excellence. And what it is, it's a series of tests that demonstrate your competencies in the field of air conditioning and refrigeration and heating. And so there's not just one test, there are a series. Basic air conditioning technician, gas furnace technician, oil heat technician, that sort of thing. So when you go to your potential employer and you say, I have a good driver's license, clean, I have my EPA, and you'll say, okay, that's good. Everybody else who's walking in the door has this. And you'll say, I have a degree in air conditioning refrigeration. That's something. And as you continue, you say, I've continued my education with these stackable credentials, micro-credentials from NATE or other companies. ESCO does something similar. Then now you got something that you can talk about. So I realize I'm kind of going through this lightning speed, so just bear with me. And you also, everything works okay, I'll be able to download this onto Blackboard and you can watch it again. So, Chapter 2 was about safety. So I think everybody has shoes that are okay for the shop. Some are better than others. What I can't let you do is wear any kind of open shoe. You know, flip-flop, bedroom slippers. Believe me, I've seen it all. Those you cannot wear. A good shoe that covers your feet. When we start to braise, it's preferable that you wear long pants because you do not want to get any braised material, any hot material on you. You should bring your safety glasses because my intention is that when I get you in a lab, to have you do hands-on lab work. That's why I want to have you. And I really apologize for this, you know, COVID-19 setup. I would prefer that you would be using your hands at every time I see you. But I will tell you this, I will make up for it before you graduate from this program, I assure you. Bring your safety shoes, bring good safe shoes, long pants. You should also bring in work gloves and most importantly, safety glasses, because I don't want to see you lose an eye. Everything we do in the labs is for real. This is what it's all about. So I want to make sure you're safe. Now, when it comes to safety, the number one workplace accidents are what's called slips, trips, and falls. So right now, the shop floor looks really good. It's pretty clean. There's no cables on the ground. There's no acetylene tanks here. There's none of that sort of thing going on. But that's not normally the case. So if you're walking and you're carrying something and you're focused maybe on the weight of that thing that you're carrying, then and if you don't look down, you may stumble your toe or you may trip on any of those number of things that you find. If you're doing new construction as an installer, many of you will be doing that. It's sort of an entry-level path. Then you're out there where they're building a residence or a commercial building, and you got workers all over the place, and they got cables running across, they got building materials. So slipping, tripping, and falling is a very real, and it's the most common accident out there. So your best way to avoid that is to be aware of your environment, to look before you step on something and walk, and watch where you're going. So if that's the most common, the most deadly has to do with electric. So I have my controls class. They just brought in that air handler there, and the air handler that's over your head. You know, what's your name again? Patrick, over Patrick's head. They're not connected. So your danger is not the thing falling on your head. I'm pretty sure that's not going to happen. The danger is you're going to go up there, you're going to be wiring that, and so I associate the most dangerous and deadly thing we do is handle electricity. Every one of our residential units uses 240 volts AC. Every one of our units of any kind, whether it be heating unit, cooling unit, they carry enough current that will absolutely kill you if you get electrocuted. Most people don't get electrocuted. Electrocuted means I was killed by the electricity that I received. Most people get electric shock. But let's just think about that. In order to work on this unit, the students have to go up either that ladder or that ladder. And if you're all the way up there and you're trying to focus in and get the wiring correct, which you will have to do, and you did not realize that there was no power, that the power was off, and you get a shock, even a slight shock, what's your reaction? Usually you jerk. Maybe you jerk back. And if you're on a ladder and you fall from the ladder, well, let's take a look at the surface here. It's concrete. It's going to hurt. So it's the association of how you get injured after you get that electric shock that can be far worse. You know, you may just pull back your hand, and air conditioning, air handlers, and condensers, outside units, none of this is put there for the convenience of the person working. It's always installed with a way of, oh, I don't want to see it, so I won't install it away from it, or I'll tuck it up here or I'll put it in this closet. So you're going to spend your entire career squeezing into something in order to work on these units. That's going to be part of your life. You're going to spend a lot of time on roofs, a lot of time on ladders, a lot of time crawling in crawl spaces. So I always tell them the best place you'll ever work on a unit is right here. This is going to be the most controlled, the most flexible you'll ever have. So enjoy it while you're here. So electric shock, that's what you got to watch out for. So the reason why you get an electric shock, this one is mitigated somewhat because you see that the legs of the ladder is made of fiberglass, a non-conductor of electricity. But, you know, what if it's a metal ladder, which you shouldn't use for electric, but that may be what they have out there. So what happens in electric? Electricity follows a circular path. Follows a circular path. The word circuit comes from, the etymology of it is the word circular. So in order for a circuit to be a circuit, and I'm not trying to get into HVA 122 electric, but the three things you need is one, you need a power source. The second thing you need is wires that connect them. And the third thing is a load. The load. The load is, in this case, when a shock is you. So here we have, let's say we have a box here, air handler. The air handler is that thing right there, or that thing over there. What's inside of it? An evaporator coil that absorbs the heat from the space that we're conditioning, a blower motor, and some printed circuits that are up in there. And there's some other electric stuff, a lot of electric stuff. So you're working on this, and maybe this is in the crawl space in the overhead, and you're here, hands there and there. And here we go. You hit the power source, that's this. The wires are your arms. And the load is you. Or you have one hand here and you have one hand, you're outside on the condenser, ground. It still becomes a circuit. And that's how you get an electric shock. That's why, where I come from, for 30 years I worked for the MTA, those guys always worked on the third rail when it was hot. They would put huge rubber mats down, and then they would be able to go to that third rail and pick it up and move it around, just as if they were birds on a wire, right? So when you find that ground, when you become the circuit, power source, wires, and you're the load, that's when you get an electric shock. So other safety items that I want to cover with you, and all this stuff is in my learning module, but I figure I'll go over the highlights of that, is chemicals in the workplace. You as an HVAC technician, you're going to work with chemicals. Sometimes those chemicals are refrigerants. So sometimes they're refrigerants. Refrigerants are chemicals that are designed to operate in two states, either as a vapor or as a liquid. What do refrigerants do? What do these containers do, the chemical inside of them? Well, they absorb heat, and at other times they release that heat. Using the air conditioning system, using the evaporator, and using the condenser. So they're good absorbers and good at releasing heat. So refrigerants have a toxicity classification, and they have a flammability classification. And that is, remember that one society I said, ASHRAE? So American Society of Heating, Refrigeration, Air Conditioning Engineers, ASHRAE. They have a standard, and it's called ASHRAE Standard 34. So ASHRAE Standard 34 classifies refrigerants as its toxicity level and its flammability level. So a refrigerant that is non-toxic to breathe is classified as A. A refrigerant that is not flammable is classified as 1. So we have A1. So A1's a really good classification for a refrigerant, right? So that means that when you're out here and you're going to be handling refrigerant and some of it gets released to the atmosphere, number one, that is most definitely going to happen. It probably will happen every time that you're handling refrigerant until you get used to it. So you breathing in refrigerant in this room you might as well put that as a given. So that's going to happen, but we're going to use only A1 refrigerants. And there's a list of them. HCFC-22, HFC-134A. What else we use here? We'll stick with those two for right now. So all these are A1 refrigerants. Now, an example of a B2 refrigerant is a refrigerant that uses ammonia. For example, ice machine factory sometimes have refrigerants that use ammonia. So it's somewhat flammable, and it is very toxic if you've ever been in a room to have it. So ASHRAE Standard 34 measures a refrigerant or classifies a refrigerant as to its toxicity and flammability. Flammability does not mean that what it means is that can it burn? Yes. But if you remove the flame from it, it stops burning. One that's highly flammable, you touch it with fire and it just keeps on burning. So now, let's take a look at the question I posed right here. Let me just check this.